Okay, that's done now, Makhan.
Brilliant. Thank you, Reese. So welcome to all our colleagues and esteemed guests at today's seminar. And today's seminar is being organised in partnership with ourselves here at Birmingham City University and our partners, the International Magnesium Association, and also the Consul General of India team here in Birmingham. Today's seminar is all about inspiring and educating about the wonder of magnesium. And today you'll be hearing from some amazing speakers who've got several years of experience in this material, this wonderful material. And this seminar is also part of Birmingham City University's series of events this year, which are helping to celebrate 75 years of India's independence. And we're kindly joined today by Mr. Hitesh Saxena, who's from the Consulate General of India, Birmingham. And so today's agenda, we're going to be having some wonderful opening speeches from esteemed colleagues. So I'd like to first of all hand over to our Pro Vice Chancellor, Professor Hanifa Shah, for the Faculty of Engineering and Computing. And I'll hand over to her to give the opening remarks. Thank you.
Thank you very much, Makhan. Can you hear me okay? Brilliant. Okay, so I'd like to give everybody a really warm welcome to Birmingham City University, and of course the faculty that I head up, Computing Engineering and the Built Environment. We're delighted to be running this event today. It's an important event in terms of the journey that we're on. And I'll explain a little bit and you'll probably understand that photograph a little bit more. So Birmingham City University have been in the magnesium space for over 4 years, very much led by Makhan introducing us to a whole series of partnerships that have been really, really important in us trying to help with two aspects, I think. One is in particular the attitudes towards magnesium and the kind of missed opportunities that are really important in terms of the lightweighting and the issues that we're trying to address as a world and globally. And then the other has been towards the helping to overcome technical challenges that are related to high pressure die casting, and particularly in terms of the process for particular types of manufacturing scenarios. What we've done in the past is we've hosted the International Magnesium Association members at Birmingham City University, and hence you see that wonderful picture of the partnership with the IMA plus the symposium that we ran at the campus, and we managed to take this, I think, a great picture with Birmingham City as a city as the backdrop. And you can already see from the picture we were joined by our partners in India, so we're already going beyond just the 2-3-way partnership. We were going very much global with our partnership. And I think it's really important to note that we as a university are really keen to work with industrial partners, not just in the UK, but in India on lightweighting and the electrical vehicle agenda. These are really important agendas for the future of the planet. And we really think it's important that we partner up and engage in these, in moving these, the challenges forward and trying to address them. And for us at the university, and particularly in the faculty, everything that we do, we want to bring our students into that mix, because at the end of the day, this is very much what we're about. We are here to transform and help transform the lives of our students, to give them great opportunities. And this partnership, I think, has the potential for our students to potentially go out to companies, not just in the UK, but on industrial placements in India. And that becomes really exciting for us. I'd like to particularly note the partnership that we have with Professor Stephen Brown, who's a visiting professor to the faculty, and you'll hear more from Stephen later. And the other thing to say is that we're quite keen that as we do this work together with the IMA and with our partners in India, we'd like to build on what we've been doing in the past in terms of producing output. So we have a green book, which is about thoughts and reflections on the use of magnesium. And then we had a blue book, which was about, the thoughts and reflections on Industry 4.0 and the use of innovation in manufacturing through digital technologies and applications. And there are going to be more books, and they will come out of some of the kind of ideas that we'll talk about today. And I think it's really important that we have the discussions, but then we actually produce outputs, etc., that we share with others. And I'm sure Makhan will say more about that today. So all I'll do now is hand back to Makhan, but just say I hope you really enjoy the discussions around the potential contribution of magnesium to an emerging Indian market, and hope that that these discussions will lead to lots more exciting opportunities. Thank you.
Thank you so much, Professor Hanifa Shah, and and also for your support over the last 4 years on this journey. I know that as a university, we weren't looking at this material, and I think your fantastic vision and also championing this cause has been, I think, created great momentum for us on this. So personal thanks for you and your kind support. I'd like to now pass on to our esteemed colleague, Dr. Prem Kumar, who's the Executive Director of the Munjal BCU Centre of Innovation and Entrepreneurship, called MBCIE. And Dr. Prem Kumar is based in Ludhiana in the state of Punjab in India. And welcome to the platform to say a few words. Thank you, Dr. Prem Kumar, and over to you.
Thank you, Makhan. And thank you very much. I am a President Rick McQueary, Professor Hanifa Shah, other IMA leaders from the international community of researchers, academics in the magnesium area, the industry leaders joining us today. Greetings from India. I'm very happy to be part of this event. This has two major significant outcomes for India. One, it is a harbinger of a growing relationship between the Birmingham City University and the Munjal Birmingham City University Center of Innovation and Entrepreneurship in India. Second is bringing the Magnesium Forum to India. That is an event which will certainly boost the effort in understanding this material. I consider, Makhan, this magnesium as a dark continent of metals. When I say dark continent of metals, I conducted a small test among the engineering students about magnesium, and not many of them were excited or even knew a great deal about magnesium as an element. In the coming days, with the focus of today's event and the efforts of the International Magnesium Association, I am sure we'll gradually discover new applications in not only automobiles, in aerospace, in marine engineering, in metal, sports, and wherever the critical alloys where magnesium is an important component can be used. The magnesium as a metal has started receiving attention, and I had the fortune of visiting a plant around Birmingham City University, which was manufacturing JLR components. And it was amazing to see this plant, not only see the plant, but also the amazing components they are making and the critical applications in which these components are being used. So going forward in India, we feel that beginning with this seminar, there will be growing interest because India is gradually now catching up with the EV bandwagon, and Munjal Birmingham City University and Munjal Birmingham City University Center of Innovation and Entrepreneurship is actually taking detailed initiatives in the area of popularizing magnesium and alloys for various engineering applications. but specifically in setting up a center of e-mobility where magnesium is being introduced as a metal of great potential. In later presentation, my colleague Mr. Ajay Sinha will be speaking about the center and what it is doing in the area of lightweighting and in the area of magnesium. In the area of magnesium, I personally feel that the magnesium as an element has all the potential of a new revolution in lightweighting and in sustainability, efficiency. We have to address critical issues in identifying applications, developing right alloys based with magnesium, and bringing the industry buy-in. I think when we talk to industry, the major issue that comes across is the change that magnesium, or any, for that matter, any change that brings a change in the working or the change in the setups. So I'm sure with the effort of the Center of Innovation and Entrepreneurship in Punjab, and which may have a footprint across India in promoting magnesium as an alloy of future, and as holding immense potential for bringing sustainability, efficiency, and productivity in various applications. I welcome all the delegates from the Indian side of the International Magnesium Association, and I'm sure the deliberations in the seminar will lead to more understanding of the promotion potential of magnesium in various applications. All the best to the participants, the speakers, and the researchers. Thank you.
Thank you so much, Dr. Premji. That was a fantastic welcome. And I know when Dr. Prem went to Meridian Lightweight Technologies when he was here in the United Kingdom in 2019, he did have a chance to actually physically see die-cast parts made out of magnesium. And I remember him saying he was amazed how lightweight. I remember him holding a cross-car beam destined for Jaguar Land Rover and seeing such a large part that weighed very little, and he was able to hold it with both hands. So I know from first experience, Dr. Prem Kumar has seen the wonder of how lightweight magnesium is. And I'd like to now pass on to a very special guest, the IMA president, Rick McQueary, who's calling us from North America. So we welcome you to the platform, Rick. Thank you so much.
Well, thank you so much. It's an honor to be here, and it's exciting to see the growth opportunities that are developing in India. Thank you again for the opportunity for the International Magnesium Association, the IMA, to be part of this online event. And the IMA is pleased to work with our longtime partner, Birmingham City University, to raise the awareness in India of magnesium and the benefits there are for magnesium. My name is Rick McQueary, and as mentioned, I'm the president of the IMA, which was founded in 1943 as the global voice of the magnesium industry. The IMA is an independent membership organization. We're not focused on any specific region or country, but the global industry as a whole. The IMA consists of a broad group of members across many spectrums. We have metal producers, extruders, die casters, recyclers, universities and research institutes, equipment suppliers, and end users as members. Today, I just want to take a few moments to share with you some of the ways that the IMA supports the magnesium industry. We do that by actively promoting the use of magnesium in material selection, and that's an important one there. Magnesium, as many of you know, is little known in some industries, and we're hoping to change that and press its presence. We do that also by representing the global interest of its members. And in these kind of times today, with concerns about the magnesium supply, that's been very effective for the industry as a whole, as we've been able to reach out to industry groups and to work together to promote the use of magnesium and its supply. We do that by providing research and education to actively address environmental, health, and safety issues. And there are many of those, many concerns in the industry today about that. And we provide accurate and timely statistics and other information about the magnesium industry. The AMA provides outstanding support to its members through global industry events, places where you can network, such as our annual World Conference, where we can share knowledge and best practices. And I'll talk more about that in just a second. We recognize awards of excellence, those in the industry that are leading the cutting edge in the use of magnesium and its applications. We have networking events and sponsor events such as this so that you have opportunities to build business relationships. And we put on webinars and member dialogues to give you opportunities to hear and to share information and updates of what's going on in the industry. Here are the details of our World Conference coming up in Barcelona, Spain this coming August 29th through 31st. We hope that you'll mark the date and save it as we gather together to learn what's going on in the industry of magnesium. It's been over 2 years since we've gathered together, and we're excited to gather in Spain and meet once again. And then finally, we want to make sure that you understand the value of our membership. As I said, not only do we have special member pricing for our IMA events and conferences and so forth, but we have ties with other industries and other associations, which we have partnerships and bring arrangements for you to be involved in. We provide direct access to industry information and newsletter updates, which was very important this past year as we saw increasing changes in magnesium supply and magnesium pricing. We'll give you the latest information on that. And we provide opportunities to network with global industry leaders. So there's a lot of important managers, universities, engineers we give access to, and we help you make those international connections to markets and product distribution. And we're looking to the future. As mentioned already, we have created a sustainability committee who's looking into ways that together we can advance sustainability and reduce carbon emissions. And we're encouraging and promoting the use of new technology to improve energy efficiency in the production of magnesium. And we're looking for ways to assist in the expansion of markets that use lightweight materials such as magnesium. And we see tremendous opportunities for growth in aerospace, battery storage, and especially electric vehicles. So again, I want to say thanks in advance to all of you who are in attendance today. Looking at the list of distinguished speakers and subjects being presented, I think that you'll find the information and the event informative and useful. And if you have any questions at all about the IMA and how we can partner together to grow the industry, please feel free to reach out to myself or our Executive Vice President Lee Houghton. And thanks again for the opportunity, and I hope that you enjoy the online event.
Thank you so much, Rick. That was a fantastic opening in terms of giving us an overview of the International Magnesium Association. And I think sitting on the European Committee, I can testify it really is a wonderful group to meet up on a regular basis. And pre-pandemic, I had the great opportunity of meeting colleagues at various European Committee meetings, and you have some great companies on board the IMA, including colleagues from VW Group in Germany. And it really is, as you said, a great opportunity to benchmark and learn from one another. And I'm hoping that colleagues from India will take a keen interest in the international conference in Barcelona, as you mentioned, in August. And towards the end of this seminar today, Martin Tauber will be giving further information about that. And indeed, if any colleagues in India would like to attend that conference, please do feel free to reach out to either myself or Dr. Vijay, who will be closing the remarks today, and also Dr. Prem Kumar, who we're working closely with in Ludhiana as part of the Munjal Foundation Centre of Innovation. Okay, thank you so much. And I'd like to now pass on to my esteemed colleague, Mr. Hitesh Saxena from Consul General of India here in Birmingham, just to say a few final words before we start our formal presentations about India at 75 and the electric vehicle agenda here in India. The platform is yours, Mr. Hitesh. Thank you.
Hello, good afternoon. This is Hitesh Saxena from Consulate General of India. Hello, good afternoon. So, first of all, thank you very much for including me in this event. I'm very happy to be here, and I also see a lot of promise in use of aluminium in the electric vehicle revolution that is taking place. India is also trying to have a transformation into electric vehicles. We had a timeline of doing a complete transformation till 2030, but now it seems it has been slowed down because it will probably not be possible. But anyway, the use of magnesium in the use of electric vehicles will be, I see a great promise in that. And I think such events can help a lot in promotion of use of magnesium. Thank you very much for including me in this. Thank you.
Thank you, Mr. Hitesh Saxena, for those fine words, and also for your wonderful support in Birmingham City University, working with you to promote the India at 75 agenda, which is, of course, a very special year for India. So I'll now hand over to our first expert speaker, Professor Stephen Brown. Professor Stephen Brown is a visiting professor at Birmingham City University and has in excess of nearly over 40 years experience of this wonderful material. And I'll hand over to Professor Stephen Brown. Thank you, Steve.
Thank you, Makhan. Firstly, good afternoon and good evening to all of our distinguished participants. And I'm grateful to be able to just give this very, very brief introduction to magnesium and magnesium die casting. I've been tasked for 15 minutes, so I've had to keep it very basic. So if anybody is really experienced in magnesium, then you'll probably know most of the stuff that I'm going to be presenting today. But a brief introduction to magnesium, and if you could move on to the first slide, please. I'm going to be just discussing why magnesium, which is just all the major points as to why magnesium is of benefit to the markets. I'm just going to compare hot chamber to cold chamber because that's a common question that seems to be asked. So just going to cover the very basics, obviously. Purposeful designing, there's lots of innovations now in designing that's progressed over the 20 years that I've been involved in automotive, certainly. And really what has held magnesium back in the past. So some of it is based on experience and what I've seen over the years that is really holding it back. If it's such a good material, why aren't people using it, basically? Magnesium, well, it's the lightest of all structural natural materials in the periodic table. It's 75% lighter than steel and 33% lighter than aluminium. From experience with steel tooling, it's far less aggressive than aluminium. I was also in the aluminium die casting industry in New Zealand for several years as well, so I have that comparison too. and steel tooling will generally last around twice as long as an aluminium die equivalent. And with the right volume that we're talking about, then that can be very cost effective. That's why die casting in general is basically a higher volume process that is very cost effective in the industry. It has excellent heat transfer properties and fire retardant properties, which is why they're now discussing aerospace. It now encourages it will transfer the heat and keep the heat, so there's less chance of any other combustible materials within the aircraft from setting on fire. So that's the way of looking at the moment. The very high impact resistance designed for crash in the US and the EU. That's why the automotive are looking at it from a structural perspective. The main reason why it is chosen is it has a very high strength to weight ratio. So it's excellent for designing structural parts in critical weight areas, such as crossguard beams, such as front end carriers, and some of the main structural areas of automotive. It can be cast in net shape. It's a major benefit when developing for carryover packaging environments and fit and finish. That's something I've experienced a lot through there as well. And when you speak to some of the OEMs, they generally don't really, they find it very difficult to cost that sometimes. So there are major benefits in their assembly process, etc. It's fully recyclable. It's unlike composites such as wind turbines, etc. They're promoting that. There's lots of wind turbines now, and my question has always been, what are those wind turbines made of? Is it fully recyclable, or are they just going to chop them down and let them stay in the sea for hundreds of years? Magnesium can be produced from seawater. It derives from seawater. It's magnesium bearing minerals that you can that are ores as well, which offer abundant reserves. It's the 8th most abundant material on the planet. Firstly, hot chamber. Now this is something that I had quite a lot of experience when I first joined the last company I was at, Meridian, and we did have a manufacturing process, a company that was manufacturing here in the UK, but they went bust in the end, and now there isn't any hot chamber volume manufacturers that I'm aware of in the UK. But I have now retired, so that might have changed in the last year. It's mainly used for high volume but smaller parts. And they normally are smaller die casting machines than you'll generally find with high pressure die casting. The advantages are it's generally cheaper. It's seen as being cheaper. There's less investment because it's smaller dies, the process, etc., and the footprint of the machines and everything else, and the faster cycle times. There's a smaller melt bath as well, so it's easier to manage. Disadvantages: it's the submerged gooseneck, which is used as transfer, metal transfer. It constantly blocks up, etc., and it generally was a problem for a lot of manufacturers. But there are problems in other die casting methods as well. All I'm doing is covering some of the disadvantages of this particular process. Furnace and preheater has to be moved for gooseneck changes. Whether that has changed and whether the technology is better now, then I would hope it is, but that definitely needs to be looked at, which I cover at the end of the presentation, because these are some of the areas in which it massively needs investment, especially in the manufacturing processes. It seems to have just stood still, in my opinion, when you compare it to the aluminium industry and lots of other industries. Cold chamber can be used for all a variety of sizes. it's you could use it multiple cavity, etc., or large parts single cavity, which is what I was generally employed in manufacturing, doing the large pieces such as crosscar beams, single part crosscar beams, and front end carriers, etc., and rear closures of vehicles. The biggest machine we had was 4,500 ton. I know there are further ones being developed by other OEMs. Idra, I believe, are developing a 6,000 ton die caster machine now. So that's soon going to change. The advantages are as a large metal bath, more stable metal temperatures in general. And these are general advantages, obviously. Minimal melt loss as metal runs through heat tube, and higher metal temp for better flow. No moving parts, but the pump can be changed very quickly and is easier to clean. You have other pumps that are sitting there waiting, that are ready, and you can just change it and put a new one in. So you don't have to move anything else. Disadvantages, what I've found is its expense, really. The investment, if investing in a larger machine, because it's a larger footprint, dies are larger, so the structure of the building needs to be needs to cover for a 30-ton crane, etc. So the general investment on manufacturing here is pretty high. You can decrease that by multi-cavity, but obviously there we're talking about major volumes, and each die caster machine. My rule of thumb was always something in the region of you have to have about 120,000 per year to really justify one die caster machine. But different places vary. Pumps and tubes require high maintenance. Designing, now that's something that I've had a lot of interest in when I first joined Meridian, because I was a product development engineer, and there's some very interesting improvements that have been made over the last 20 years. There's innovative design optimizations and techniques available. This is showing structural FEA optimization. It allows you to optimize the magnesium design precisely to your needs for structural performance in the vehicle, functionality, the integration of attachments, etc., and manufacturability. And you can generally go through all of these if you have experienced PDEs working on this, and you have personnel who are trained in the use of these techniques. Then it saves a lot of time and money, and it can be done very quickly if necessary. You can provide an innovative design approach that maximizes the benefits and reduces assembly costs through weight reduction. There are major advantages which we consider when we consider electrification and the growing public desire for non-plastic and non-composite, fully recyclable natural materials. That's the way the general public are going, and it's changing all over the world at the moment, and it's growing pretty fast. So I think magnesium is something that will be promoted a lot more in the future. Predictive magnesium cast quality. Now this is a magma simulation of a product, and I just really wanted to show you this is showing different areas of the die, and each different color shows different gates and entry points, so you can understand how the part is forming in the die. And it's extremely important to try and push any air out through overflows, and it also allows you to plan where overflows can be. And if you've got experienced people that are studying this, then you can predict fairly closely as to what's going to happen when you start die casting your part, which is very important because it's an expensive process, and you don't want to make any mistakes in the die and have the die keep going backwards and forwards, making changes. I'm not sure whether you can run that, can you, from there? Can you run that simulation on the previous slide? Or is this a PDF? Yeah. And that shows you the process, as it's making its way to the overflows and where you want it to end up. And it shows the fill, and you can predict lots of things from this software, such as air and flow, and many other things that you can use it for. Okay, next slide, please. Sorry to run through it all so quickly, but there'll be questions later on if anybody has it, but you can see that it's basics. And my question is, if it's so good, why is it not used more? Some of this is opinion based on my experience through the years, but I believe it's pretty standard. The main thing is pyrophobia. So what's the first thing people think of when we mention magnesium? And it's generally fire, which is terrible, really. But it's an exciting thing for children when you're at school, when you have that little magnesium strip and you light it up. So everybody imagines that it is highly flammable, but it isn't. It is not. It's not that easy to set on fire. But as with everything, as the volume changes and you have a really small volume, then you can heat that incredibly small volume up to its ignition temperature very quickly, such as wood, such as aluminium, even such as lots of other materials. So it's got a bit of a bad press because of that, because it burns so brightly when it does eventually set on fire. And there are videos online that show you how difficult it is, and there's also spectacular videos of magnesium fires, but there are videos to show you how difficult it is to actually ignite. Especially when you're using it in the large components such as we do. There's a severe lack of knowledge, which is why I firstly teamed up with the Birmingham City University, and thank you for the efforts that you're making to try and promote the material, because although I'm not employed anymore in the magnesium industry, I've only just retired December last year, then I still feel as though it's an underutilized material, and I will take opportunities when I can to promote the material. It gets a bad press, especially in its corrosion resistance and its fire retardant properties. Creep over 150 degrees centigrade. I hear designers and developers talking about creep, etc., but there are new alloys that have been developed, and the IMA can speak about later on, that can cover that too, such as any material, such as aluminium, everything. There's lots of different alloys that you can use if you have a particular issue. Application experience eases old stigmas. It does. As you get used to it, then you start to forget about those old stigmas of pyrophobia, etc. So it's really experience that people need, and designers within the OEMs. Lack of global magnesium supply since the European closures. The majority of the supply is quite focused now on China and some other manufacturing sources, but that has to be shared around. So I would like to see others open up as the market increases. Investment in advanced manufacturing techniques is desperately needed, which is what I mentioned earlier. A general cast tooling investment issue with low manufacturing OEMs. It's very, very difficult to get prototyping and manufacturing for low volume OEMs. We tried something a couple of years ago with Birmingham City University, but the business case did not work in the end. But I would like to try and develop something to make it attractive for the low volume manufacturers, because in North America it's okay because there's some very high volume manufacturing over there, but in Europe it generally is lower volumes, and we need to try and find some way of prototyping and achieve some of the properties that you will generally get from high pressure die casting in a prototype component without having to spend money on an additional tool that you cast a few hundred parts and then throw away. Investment cost for lower production volumes, which is what I've just mentioned. and prototyping techniques that match the properties. And I think that's it. And I think that's 15 minutes. Did I go over?
No, that was perfect, Steve. Thank you so much.
Sorry it was so brief, but that's what I was tasked to do.
No, thank you so much, Steve. That was an excellent
You're
presentation.
welcome.
And again, as always, thank you for your wonderful support. I know you've got such a passion for this material. And for those that don't know Steve, Steve used to be also Managing Director at Meridian Lightweight Technologies and has worked with many OEMs across the world, and including Porsche, who were introducing magnesium on the roof of one of the Porsche cars. He's also led on several Jaguar Land Rover projects for the new Land Rovers that were being developed a couple of years back. And he's also worked with Ford as well as a key player in Valencia. So thank you again, Steve. I'd now like to introduce our special guest keynote speaker, Mr. Ajay Sinha, to the platform. Ajay Sinha has over 40 years experience within the manufacturing sector, having worked for Hero Group for several of those years. And he is now director of the Munjal BCU Innovation Center Steamhouse India project in Ludhiana. And I'd like to give a special thank you for him for giving today's keynote speech and welcome him to the platform. Thank you, Ajay ji.
Thank you, Makhan, and thanks to IMA to invite me for this particular session. And I represent Steamhouse as told by Mr. Makhan Singh. And we take it as an honor that Steamhouse has a opportunity to represent the e-mobility and future of Indian transport industry before you. And during this session, let me do my best to explain to you that how the e-mobility is being driven in the country and what all are the implications and what all are the initiative that Indian industry is taking to ensure that the e-mobility becomes a stable feature in our country as far as the transport industry is concerned. And to start with, I would like you to take you to the next slide, in which we have just shown you that environment has started giving an impact in our country also. And these are a few pictures which has been posted here. And it has these are the photographs which is showing the situation of foothills on the Himalaya mountain. And you can very well see that there is a lot of flooding taking place, landslide taking place, uprooting of the trees are taking place, and it is disturbing the entire environment in the region. And it has an implication on the plains also, because when this flood water is reaching to the plains, it is giving an impact there also. And India is not a country which is untouched by the changing environment and the global warming. India is being affected every year now, and that is what is the situation in the country. And when COP26 took place in 2021 at Glasgow, the Prime Minister of the country, he made few announcements also, and he made certain commitments also, which is being realized in our country now. And the commitment is that by 2030, there will be a reduction on the carbon emission by 1 billion tons. And by 2070, net zero carbon emission is planned for by the country. And those realization can best be done when today we take the measures and its corrective steps, so that these things do not become difficult with time and becomes a easier task for the country to achieve. And that's the objective with which our country is working. And besides taking few steps like going for the solar power at the western part of the country where the deserts is there, and that is where we are placing the solar power stations and generating the power. There are certain windmills also being planned on the coastal areas, and lot many initiatives is being taken by the government of India to ensure that we deviate from the coal-based power generation to the natural resource-based power generation. That is the step as far as mobility is concerned and the transport industry is concerned. India is a country which is producing plus to 20 million motorcycles, scooters, bicycles, and three-wheelers. That is what is the production capacity every year and consumption also of these vehicles. Besides this, India has a passenger car industry also, which is quite matured and very high in the volume of production. Transportation industry like commercial vehicles are also there. Automotive industry, tractors and other vehicles are being done for the purpose of serving the agriculture industry also. So that's the business that India is doing as far as the mobility is concerned. And when this is being done, then obviously there are challenges which is being faced, because when the government has made the commitment at Glasgow, so there is a very strong push from the government of India that country must move to e-mobility, and that is what is happening in our country. And when it comes to e-mobility, it is being taken as a challenge by the industries who are currently in the business of producing and selling the ICE vehicle, that is internal combustion engine vehicles. But now that they have to migrate and they have to move towards the electric vehicles, and that is what is there. And the objective of the country is that not to remain locally established entrepreneurs and organizations. We must be able to be seen very prominently in the global business, as has been being done in the ICE vehicle business also. So that is the objective amongst all our ICE vehicle suppliers and production people. And with that objective, we are working in the country. Now, what is happening in our country, that in the process of changing over from ICE vehicle to e-vehicles, where things are getting stuck up is that our country does not have the kind of a technology as of now, or it is lesser on the technology as far as the design part is concerned. And what is happening that our manufacturers are picking up the vehicles which is being used for the ICE purpose, internal combustion engine purpose, and they are making certain tweaking and changes into it, and they are trying to place the battery and the electrical system so that it can be converted into the electric vehicle. But issue is that when it is being done, then the basic structure of the vehicle remains the same as what being used by the ICE vehicle. That means same very steel structure, same very other components are being used, which otherwise was being used for the purpose of the ICE vehicle. And when we place the batteries and other parts which is required to be converting it into the ICE e-vehicle, then the weight of the vehicle goes high. And when the weight of the vehicle goes high, then it becomes very difficult for making a efficient vehicle which is good for the electric vehicle. And that is where first constraint comes, because the technology, the entry into this e-vehicle business is quite new for the country. And that is what we are calling as a conventional design. And that is what is to be changed over. And then it is to be converted into the purpose design. What is meant by the purpose design is that every vehicle, whether it is two-wheeler, whether it is bicycle, whether it is rickshaw, whether it is utility vehicle, passenger cars, all are to be taken on the drawing board, and it is to be seen that how can it be converted into the e-vehicle so that it becomes light in weight and yet it becomes very efficient. And that is where is the role of the light component metal like aluminum, like magnesium. It has a major role to play so that manufacturers can start designing their product and vehicles suiting to the aluminum and the magnesium per se, and it becomes the base component rather than the steel and gets replaced. And then you find that yes, these are the vehicles which is being made, and it is efficient in terms of the low weight, which we are calling as the light weighting, and also it becomes efficient also and is capable to run on the as a prime mover. And that is what is the objective with which people are working. And obviously it is going to take little time, but yes, people are catching up with the time so that they can overcome this kind of a situation. That's what is happening as of now in the country. As far as your magnesium is concerned, our country has the magnesium mines, and mainly it is located in the eastern part of the country, western part of the country also. And issue is that as of now, our country is very highly matured as far as the aluminum mining is concerned. Magnesium mining has not been the focus area, but now it is becoming a focus area. And since the mining is yet to be developed to the level that it becomes a highly commercial as well as the cost effective, and that is where the cost of extraction is of the raw material is on a higher side. There is a process and technology also which is yet to be developed and to be made more effective. Resources availability is also one issue which is required to be taken care of, and growing demand of the material in the automobile industry is also to be met, and that is where is the target for the mining industry also, so that they are able to develop magnesium industry in the country which is as good as and as efficient as aluminum industry. That is what is being done. Now, as far as the government of India is concerned, government of India is supporting the entire e-mobility business very effectively, and they have started financing the research and development activities also. They have asked for certain targets from the people who are in the business of manufacturing, and they are calling as a production link incentive system, so that when you produce and sell a particular product, then the government of India offers them the incentive. In the screen, you will find that there are certain parts and components which have been identified to be converted into the lightweight, like bicycle industry. There are about 10-12 parts which is shown in the screen. As far as the e-vehicle industry is also concerned, there are certain parts which is shown in the screen, and these are the few parts which has been listed here, but it is indicative, and there are lot many things which is required to be done by the industry and by the government of India, and that is where the push is coming. As far as e-mobility is concerned, yes, there are major players in the country who have started working, and they are in process of producing the e-vehicle. Few are the names which is mentioned here, like Ether Energy at Bangalore are there, Hero Electric, they are at Ludhiana, Okinawa at Gurgaon, Hero Motocorp at Gurgaon again, Ola Electric is there located at down to south at Tamil Nadu, then Bajaj Auto at Pune, and TVS at Chennai. And they are the major suppliers who are in the business of the vehicle production. Besides that, there are people who are already working in the four-wheeler industry also, like Mahindra and Mahindra is there, Tata Motors is there, Hyundai is there. So they are also in the business of the including our, I would say, the few global brands like Mercedes-Benz. They are also in process of launching the e-vehicle in the country, and towards end of this year, we can expect Mercedes-Benz also coming out with their product range also in the country, and that's how the entire scenario in the country is going to change. Besides that, there are people like Hero Motocorp. They have gone ahead with the battery swapping, because when we are in the e-vehicle business, first and foremost requirement is that vehicle should be running uninterruptedly, and that is where Hero Motocorp has gone ahead with a collaboration and partnership with the Gogoro of Taiwan, so that the battery swapping system can be well established in the country, so that the owner of the vehicle need not have to wait for the battery charging, and he can swap the battery and move on also. So is with other organizations like Reliance Jio, one of the topmost organization business houses in the country, Hero Motocorp again. They are tying up with Bharat Petroleum, because Bharat Petroleum and Indian Oil Corporation like HPCL, Hindustan Petroleum, they have the petrol filling station and diesel filling station countrywide. Very strong network these people have. So people like Reliance Jio, Hero Motocorp, they are joining hands with them, and they intend to utilize their facility of PPCL, which is a very strong network in the country, for the purpose of charging purpose also. So that's what is happening in the country. And as far as the three-wheelers is concerned, Reliance has joined hands with the Mahindras. Mahindras are already in the business of three-wheeler production also, so they are also working with them, so that a very strong network as far as the charging can be placed also. Power surplus initiative is already taken place by the state governments, because that is also one strong feature which has to be coming in picture. And Government of India and state governments have started working towards it also, so that power does not become a restriction and constraint for the purpose of launching of the e-vehicle effectively. In nutshell, I would say that yes, there is a very strong movement taking place in the country, and we are very hopeful that over a period of few years, the entire scenario of the country is going to change. And what we are producing, plus 20 million two-wheelers, including the bicycle and three-wheelers as of now, will definitely be getting converted and will be minimizing the usage of the ICE vehicle. And that's how we intend to meet our target, which we have committed ourselves in Glasgow and COP26. And country is very hopeful that we should be able to make a good out of this e-mobility business. Thanks for your time. Thanks to Mr. Makhan Singh, and thanks to everybody for giving time and allowing me to make the presentation on behalf of STEAM Hub. Thank you so much.
Thank you so much, Mr. Ajay Sinha. That was a really wonderful presentation and really sets the scene for us in terms of what's currently happening in India in terms of the transport market. And I'll have the great privilege of spending some quality time with Mr. Ajay when I'm in Ludhiana later this year, and keen to discuss more about how we can look at setting up magnesium labs and innovation labs around India, starting in Ludhiana, to kind of educate both our young people to understand the power of magnesium, but also our industry leaders. So we're not all looking at steel and composites and aluminium and the traditional materials. Thank you again, Mr. Ajay Sinha, for a wonderful presentation. I now have the privilege and pleasure of introducing three presenters who will be giving different experiences. All three are IMA members, and we have today Mr. Akshay Ghai. Following him, we'll have Mr. Suraj Navekar, and then following that, we have a recording from Professor Trevor Abbott. So these are three wonderful members of the IMA, and I'll hand over first to Mr. Akshay to have the platform to present. Thank you, sir.
Hello, Mr. Makhan Singh. First of all, I would like to thank IMA and Birmingham City University for giving us this opportunity. I think this topic is very interesting, especially in India. I mean, India is growing in terms of automobile, steel industry, pharmaceutical, and all individual industries. So myself, I would particularly here, our subject is mainly on the growing Indian steel industry. So I would like to start my presentation. So Elmamet, it's an international group. Our head office is based in Germany. And Elmamet India, we have a daughter company, which is 100% owned by Elmamet Germany. So maybe next slide. Okay. Yeah. So the growing Indian steel industry. So as I have said, so our office, Elmamet India, as I said, it's a 100% subsidiary of Elmamet Germany. Our office is in Delhi, Noida. And then we have also, our warehouse and plant locations in Odisha, Karnataka and Jharkhand, different parts of India. And then our head office, as I have said, it's in Endring, Germany. This is our head office, and where all my colleagues also are representing here. They must be hearing also. So next, one sec. Yeah. I cannot move this, wait. Yeah, next slide. So yeah, so hard facts on Indian steel industry. So as we see, currently India is the second biggest steel producing country in the world. India currently in this year 2020 till we produced around 107 million tons of steel, and by estimates, by 2030, our Indian government target is to reach 300 million tons. And I think which is not very far away, the way, the government is taking initiatives, and all the private players like Tata Group, JSW Steel, JSPL, Sale Authority of India, they are taking steps. So it's not far away. Already we are seeing a lot of new projects coming on, and even in COVID times, in last 2 years, the government of India announced many new projects which are lined up, and already also some mergers or acquisition happened in last 2 years, where all the big players have acquired small steel plants and all. So if you look at this map also, I mean, after China, India is the second biggest, I mean, you can see, and then third is, I would say, Japan, and then USA. So yeah, next slide. So as we say, like if you see increasing trend in production and exports. So already, I mean, in last 2 years, India and I mean, especially in last 2 years, we have seen, and even in this COVID time, as I mentioned earlier also, that India is also focusing a lot on exports. Earlier, mainly in past, India was mainly using its steel for domestic infrastructure and development. But nowadays, even we have, I mean, if you see these graphs, so you can see there has been an increase on export, and this trend is continuing. Yeah, next. Yeah, despite as you can see in this graph, despite, I mean, our rising steel production, per capita steel consumption is still below average. Further growth, so you can expect with this graph that the target is to reach 300 million, and we are still at much, we have a lot of scope for improvement. And if you look at the world steel market, I would say that if you look at the steel market in Europe and other parts of the world, it's more or less stagnant. But India has a lot of growth opportunity, and still we have a lot of capacity. So that is the reason, I mean, steel industry is in boom. Yeah. So these are some of the major installed, I mean, these are the capacities if we just look at the steel industry. So Tata Steel, I would say this is their current capacity. Then they have another expansion plan. We look at JSW Steel, currently in private, I would say JSW is the biggest company. They are making currently 28 million ton per annum, and they have announced another 19.2 metric ton per annum. Then we have this SAIL plant, that's government plants. So they are currently at 20 million ton per annum. And JSPL, then AMNS, recently ArcelorMittal has acquired SR Steel plant, and now together with Nippon Steel, I mean, they are quite active in India. And as we see, they have announced another 18 million ton per annum project in India. This is RNL, another government plant, and then Vedanta, JSL, and other steel plants. Right, next. So now coming back, so this was the short introduction on the Indian steel industry, but coming on Elmamet Group. So Elmamet Group, I mean, it's a 4-decade-old company now, and one of, as far as I know, one of the oldest members of IMA as well. And since 1983, Elmamet, if you look at today, we are the market leaders of magnesium-based products, and especially in hot metal desulfurization and in Grignard reactions and pyrotechnics. So many years of experience Elmamet has, I mean, with our special connections with our customers and close connections with our customers, we have mastered this art of hot metal desulfurization technology, which is mainly in steel plants, which is to reduce sulfur in steel plant. And here magnesium is also used. One of reagent is magnesium. So recently Elmamet, I mean, in 2018 also acquired ThyssenKrupp Policius company, which has worldwide commission supplied around 150 desulfurization stations, which are used in steel plants. So earlier we were just into reagents. Now we also offer the technology of hot metal and desulfurization in both torpedo and open top letters. And today, Elmamet, this is what I mean, in India, recently we have started this concept. Elmamet is the only company worldwide which is providing a complete solution for desulfurization. So starting from technology to operation and maintenance to supply reagent and consumable, we work on boom model, EPC model. So we do every stuff for the steel plant in the steel making area. So, and this is our recent, and in JSPL Angul, this later I will also show some pictures of this plant. We have done this kind of the first, and we are promoting this in different steel plants now, and we are getting very good response. Next. So yeah, this was Elmamet. Coming back just to specifically Elmamet India, as I introduced earlier. Elmamet India, it's a 100% subsidiary company of Elmamet GmbH, incorporated in 2012. Since its starting, I would say now we have around 60 to 70% market share in most of the big steel plants in India in the field of hot metal and desulfurization. And we were the first company in India which successfully replaced this calcium carbide reagent
and buy safer and cheaper fluidized lime and magnesium in Indian steel industry. So we are the pioneers for, this change in the steel industry, and for that we are well known in the steel industry, not even in India, even in other places in Europe, South Africa, and everywhere else. So then successfully introduced the concept of producing lime fines. So we use lime fines of steel plant for making fluidized lime, and then supplying magnesium as market leaders, as I said. So Elmomet in India, at least I can say that we have a market share of 70 to 80%, and one of the leading supplier of magnesium granules to steel industry. And even this magnesium granule comes from our daughter company in China. And even in this crisis time, in last 2 years, we were also able to supply magnesium from Russia and Turkey as well, because we also have our magnesium-based products manufacturing unit there also. And in 21, we have recently started a new venture in the field of sensor and probes, in the molten metal measurements for. So yeah, next. So this is our Elmomet India total service and package, what we do. So as I said, we do everything in hot metal desulfurization, starting from operation maintenance of the hot metal desulfurization, then supply of reagents, which is magnesium and lime. And then there are some consumables, which are like lances, 2-in-1 probes. And then we have this lime installation facility, which we have recently done in JSPL and in Tata Bhushan Steel Plant. And then we have, obviously, this is our most strong point, where all our customers are they strongly recommend Elmomet, and we are their old partners, in technical support and all. And then we are also supplying magnesium to chemical industries, I would say, like pharmaceutical, agrochemical, and even in defense industries. So these are other than steel, we are also into chemistry industry. And as I mentioned, then sensor and probes at last, this is our new venture in molten metal measurement. So we have recently just started this product. Yeah. So this is our total model of build, own, operate. So this is just a drawing of hot metal desulfurization plant in a steel plant, which was built by Elmomet Industrial Solutions Germany, and then later Elmomet India is operating and maintaining this facility in Jindal Steel and Power Ungul in Odisha. Successfully running this plant since 2019. So, and as you can see, it's the first build and operate project in India. There are a lot of advantages. So which I don't think here I would like to go more in detail. So maybe we can go ahead with the slide. And then this is our end-to-end desulfurization solution. So you can see, like Elmomet, how as a group we do. So Elmomet Industrial Solution is looking after the technology, engineering, supply of HMDS equipment. And then Elmomet India, we prepare this lime plant. This picture is from JSPL Angul. And we have this magnesium warehouse also, where we use this lime fines from steel plant. We grind and blend it in our facility, and we supply to them in their hot metal desulfurization facility. And this is Elmomet India team, where we run 24/7 their desulfurization station. And so it's like a total package of Elmomet Germany, Austria, and Elmomet India. That's how we work together. So this is our plant commissioning in Odisha. Mr. Jindalman, who is the chairman and founding director of JSPL Group, which is a very group in India. And then this is our commissioning engineer, Mr. Stefan. This picture is from commissioning, and this is the hot metal desulfurization facility. So I could only get this picture. So, but here it is, our plant is there. Next. So this is our lime grinding and blending facility. I have already explained. So this is a more closer look. So maybe we can move forward. Next. So these are some of the references: Tata Steel, Jindal Steel and Power, JSW, SAIL, AMNS, UPL, and then Southern Magnesium and Chemical Limited. Thank you. So at last, I would again like to thank you, IMA, for giving us this opportunity. And I hope all our participants liked my presentation. Thank you.
Thank you so much for that, Akshay. That was a really wonderful presentation, and it really gave us a good insight into your company. And we are all hoping that part of this seminar that we will have people that can exchange emails and contact details, and we can
Right.
create a forum for sharing across all our partners in India and learning from best practice. And I think our colleagues Martin, Tauber and Dr. Vijay will be mentioning how to do that and the way forward at the end of this seminar. So thank you again for that.
Thank you very much.
Takes me great pleasure now to introduce our next speaker, Mr. Suraj from Ranch, and the platform is yours, Mr. Surajji. Thank you so much.
A very good afternoon and a very good evening to all who are present today for the seminar. And I would like to thank the Birmingham City University and the IMA to have given me this opportunity to present my company, Rauk Furnace Technology from Munjal, Austria. Can we go to the next slide, please? Okay. I would be explaining this presentation in 4 parts. What basically Rauk is, then what metals we are dealing with, and what are the melting solutions we are offering, and then references, and then what is happening in India with the magnesium. Next slide, please. As I had mentioned, Rauk is synonymous with the magnesium melting technology. We have been present in this industry for the last 45 years, and we have been in the forefront of developing advanced complex technologies for handling molten magnesium. And we have pioneered many challenging projects along with many of our clients in various applications for of magnesium. We are, of course, we are not only into magnesium, we are in magnesium, we are into zinc, lead, and even aluminium. Next slide, please. As I mentioned earlier, we have been a part of development of various projects across the globe, and we will see in the next slides. Next slide. Okay. You will see the journey of Rauk. We started this operation in the year 1975, and it was in the year there is a mistake here of 1968. Okay, we started with the first production of the magnesium hot chamber furnace in 92. Then we also were the first people to produce the cold chamber furnace in the year 1995. Then we went on to produce our first magnesium in-house recycling concept. Then in 2001, we went on to producing our first magnesium alloying equipment. And then in 2005, we started off with the magnesium sheet casting, magnesium liquid transportation, and billet casting. Next slide, please. As you see, in 2007, we have developed ADSL and in-cell recycling. Then in 2008, the production and the development of lead portfolio. Very interesting development was in the year 2009 when we set up manufacturing our first magnesium low pressure casting. Another very interesting project. All these projects you find are very varied and very interesting. So as I would say, we have been a torchbearer of, you can say, magnesium technology in terms of setting up different plans and different technologies to cater to every requirement of our clients. So in the year 2010, we developed the first magnesium steam production system, which was used to coat steel sheets. And this particular project we had concluded for I just saw some chat, so I got diverted a little. And this particular project was envisaged for ArcelorMittal. So you would see and this was basically, you would say, vapor deposition of magnesium nanoparticles on steel sheets. And another very interesting project came about was in the year 2015, where we developed the first magnesium and aluminum low pressure sand casting system. This particular project was envisaged basically for aerospace industry and large low volume production. We used to find that people were using gravity casting, and then the rejections were so high. I mean to say, I know companies, including a most popular company in India. I don't want to name them at this point in time. They have rejections as high as 85%. With this system, we know that we would be able to reduce the rejections up to 10 to 15%, and that too, the rejections are not based on the equipment what we are supplied. The rejections could be because of the process and the design of the what do you call molds itself. Then in the year 2017, we developed a recuperator burning system for all our equipments which we are offering earlier, which was only in electrical. Now we started offering this, and we also have a complete range of equipments which could be offered even with a gas-fired technology. In the year 2018, we changed our company's name from Fertigung Technik Rauch to Rauch Furnace Technology. And in the year 2019, we developed the production and development, that is in-cell recycling system. Now, gentlemen, there was one thing which we have missed out in this slide. We have also set up a completely greenfield magnesium extraction plant from dolomite in the year 2016 in Turkey for 60,000 metric tons, where our main, of course, we were the consultants, and the cast house was supplied by Rauch. So there was some speakers who had mentioned about, I think so it was Mr. Sinha who had mentioned about India going into producing magnesium. Of course, we can produce magnesium. We have the complete, we can offer the complete turnkey if anyone is interested in setting up of a magnesium extraction plant from dolomite. Next slide. So as we see, our services are from research and development, electrical and mechanical engineering, project management, and wonderful professional training given to our clients. Next slide. Next slide. So this is our wonderful team based out of Austria, which is headed by Mr. Martin and Mr. Peter Rauch. Next slide. You see our global footprint, what Rauch has. We are present in, our equipments are installed in about 45 countries. And we are currently handling, our equipments are handling close to 2.2 million tons per year with the pre-warming installed capacity of 800,000 tons per year. So this goes to show that practically every, I mean, we say close to 93% of the magnesium that has been melted in the world is on a Rauch furnace or a Rauch system. So as I mentioned earlier, the metals which we work, and as we play with this magnesium, zinc, and non-ferrous metals, which also includes aluminium. Next slide, please. Okay, so now these in this slide you will see we have broken down basically what are the things we do. It's like we are into melting solutions, recycling and alloying. We are into steel sheet casting, of course the protective gas mixing systems, which is very, very important for safe handling of magnesium, and liquid transport systems. In zinc, we are in melting furnaces, recycling systems, and liquid transport systems. And interesting is gravity casting for aluminum and magnesium, and low pressure castings for aluminum and magnesium. Next slide, please. Now you would see, I would like to take you all through the different slides of the, you can see the images of the different furnaces or the solutions what we offer. Now these are what we call as MDO, which are basically furnaces which are used for cold chamber die casting, where we have a melt rate starting from about 70 kgs per hour up to 1500 kgs per hour. For people who are present today in the seminar who are not aware of the difference between aluminum and magnesium, typically in aluminum we find what we call a melting and a holding furnace, but in case of magnesium that's not the case. Everything is done in one single furnace. And the dosing volume here you would see is parts weighing from, I would say not parts, the dosing volume are from 300 grams up to 30 kgs. Next slide. It's the similar this what you are seeing, but now here you are seeing the same kind of the same furnaces, but which are gas fired. The details are the same. You can go to the next. Now this is a very interesting solution which we have now in a mass and a serial production. We ideally ask our clients when they go for a furnace to have a what we call as a magnesium pre-warming unit to be plugged along with it. So what happens is the ingots before they are fed to the furnace are already heated up to 120 degrees centigrade, between 120 to 150 degrees centigrade, so that any moisture that is there on the surface of the ingots or is gone, and the time taken for melting of this is also reduced, and plus your cycle time of melting comes down phenomenally. So this is another product which we offer. Next slide. Here you would find a magnesium dosing container. Now this is basically a great concept which we have wherever you have a central melting system. That is basically one of the best examples is the plant which we had commissioned for BMW at Landshut, where they have a, you can have a separate center for melting magnesium and then transporting it to safely to the place, the cell where it is cast. So this is an image of that, and you can also see a forklift truck which is carrying the liquid melt. Now even here, it is completely protected with the protective gas. So it is even very safe to transport it from one place to another place as well. Yeah, next slide, please. Yeah. Now here you find an image of a recycling equipment. The recycling, as we said, it starts from the smallest is for 2,750 tons per annum. And as we said, we can say it goes up to infinity. So you can also have multiple cells in terms of multiples of 1,000, 2,000, 4,000 tons per annum. Then we have the magnesium alloying equipment with the melting rate of 3,300 tons per annum. So if somebody wants to have a larger facility, they would just have to add another cell. It's what you have. So for the next, from 3,300, if you want to increase it, then you can go for 6,600 ton per annum facility. It is just a duplication of whatever cell you have. This is how we have proposed our design and how it is manufactured. Next slide, please. Okay. Here we are trying to talk about some of the interesting solutions which we have. You see here, there is billet casting, then you have gravity sand casting, sheet casting, and a very, very interesting product, what solution we have developed is for magnesium chips press. Now, what happens is during machining of magnesium parts, after the part is die cast, if machining is required, there are a lot of these chips which are produced, which can be very hazardous if it is not contained clearly and kept in a safe way. So this is one solution where you can convert all your chips into a billet and once again used for your regular production. Next slide, please. Here you would find a very, very interesting. You can see on the right the actual image of a facility which is installed. This is for a low pressure sand casting system, which I just explained to you earlier. So this gives you a bird's eye view of how a system would look. So you find here there are two cells where you can have magnesium on one side, you can have aluminum on one side, or you can have both magnesium handling different alloys. This also can be done. And yeah, we have about 6, 7 such systems which are there across the globe. And we are proud to say we are probably the only people in the world who are offering such a robust technology. The next slide, please. Yeah, here there are some images of what we have done with zinc hot chamber furnaces, the recycling equipment, the zinc liquid transport system, and the lead chamber furnace, both electrical as well as gas fired. Can you go to the next slide? Okay. So once again, we are summing up whatever we are offering, whatever I have mentioned earlier. These are the pre-warming unit, the alloying and recycling, the head box for sheet casting, the low pressure casting. So basically you would see that we are there. We do magnesium, as we say sometimes, you know, we are there handling every single facet of magnesium today. Next slide. Next slide. Hello? Yeah. Here you would see the footprint of RAUC installations across the globe. We have about 584 cold chamber furnaces. It's probably a little more than this because we might not have added a few more installations. As we are talking, there is an installation going on in India. So we have not added that. There is another recycling installation going on in India as we speak. So it could be 23. And here you see that we have a liquid transport system, the low pressure sand casting, which is there. And yeah, the sheet casting equipment. As we are speaking, there is another sheet casting line that is being set up in, it's under installation in China. You can go to the next slide. Yeah, references. Next slide. We have given just a few references. We have a list of many, many more customers. In fact, what we would like to even highlight is we have worked with most of the labs or most of the centers across the globe which do research in magnesium have a system from RAUC. So, you know, that goes to show the confidence that our customers have in RAUC, even from whether it is laboratory equipments to serial production equipment to any kind of system they think they would like to think about RAUC. And you also see there are so many large die casting machine manufacturers who would love to promote RAUC as a ideal furnace supplier for their die casting machines. Yeah, next slide. Okay, I would just like to sum up my presentation by just mentioning what is the current ecosystem in India. Okay, we have cold chamber die casting cells, which are 3. We have just 6 hot chamber die casting cell, and a recycling cell which would start production from the 23rd of this month. And yeah, I strongly believe, I also would like to conclude my presentation by mentioning that India has been a laggard in magnesium, which is the most viable lightweighting metal. And in addition to what Mr. Stephen Brown and Mr. Ajay Sinha mentioned in their presentation, I would also like to mention there is a severe lack of design knowledge among designers in India, which has been a very big issue in promoting magnesium in India. By this, I conclude my presentation, and I would like to thank once again IMA and the Birmingham City University to have given me this opportunity to present RAUC. And I would also like to mention that all the people who have participated in this seminar, if they have any questions, they are more than free to ask me later at a later point or whenever it's feasible. And you can also get my email ID, I believe, from IMA, and I would be more than happy to give solutions or discuss anything to do with magnesium.
Thank you so much, Suraj. That was a wonderful presentation, and I know you've been really active in supporting to cascade this seminar to your various colleagues and contacts in India. So it's really, really well appreciated from us all. Thank you.
Thank you so much.
For an excellent presentation. We're just running about 10 minutes behind schedule, so we're just going to quickly move on to the next presentation, which is a recording. So I'll hand over to our esteemed colleague, Reese, who will set up and play that recording. Thank you, Reese.
I'm just going to make sure that you can hear this okay, Makhan.
Hello, I'm Trevor Abbott from Makhan Singh. I'm going to talk about magnesium alloys applications. So, first of all,
we've just lost the sound, Reese, if that's something you can look at.
office.
Is that better?
Yeah, thank you.
Sales office. So before I get into magnesium alloy applications, I just want to step back a bit. Magnesium alloys are a large segment. They're shown here in green. But historically, the largest segment has been for aluminium alloy. So 5,000 series, the aluminium magnesium, and the 6,000 series in silicon magnesium alloys. Require magnesium as an essential ingredient. So this is for a long time controlled. Here I have some price history of showing magnesium in red, aluminium in blue, and for comparison, the rare earth cerium lanthanum green. So you see there's been a few spikes in the magnesium price. One was in around the 2008 Olympics, and right now there's another spike with the energy shortages in China. So because magnesium is essential for the 5,000 to 6,000 aluminium alloys, the demand there is inelastic. They will pay whatever price because there's no alternative to magnesium. So when there's a supply shortage, you'll see that the price spikes up quite high. And interestingly, it's actually magnesium is more expensive than rare earth. And aluminium is getting close to the price of rare earth, which is an unusual situation. We look at the mix of the different is iron steel, aluminium and magnesium alloys. This chart shows the area of the circles corresponds to the total consumption in each. You can see that iron steel is huge. It dwarfs aluminium, which in turn dwarfs magnesium. Then if we look within each category, we can subdivide into two categories. Castings, where you produce a part that is close to the final shape, and semi-finished or wrought products, such as extrusions, rods, bars, sheets, which are then used to assemble another component. You can see there's a very different mix. Iron steel is dominated by semi-finished products, with only castings. Cast iron castings are relatively few. Aluminium is also dominated by products, extrusion, sheet. But castings is a larger proportion. Whereas with magnesium alloys, it's the reverse. It's dominated by casting, with only very, very minor applications. So there are a number of reasons, both for the difference in the relative size of the markets for the different metals, and also for the wrought to casting mixture. One of the reasons why magnesium wrought alloys are used so infrequently is strong competition with aluminium alloys, and there's a very wide range of possible properties for wrought aluminium alloys. Whereas for die-cast aluminium alloys, the properties extend over a smaller range. So the comparative advantage, property-wise, is better for magnesium casting stuff. Several other factors. One is the strong texture produced by wrought processing magnesium. Magnesium is a hexagonal close-packed structure. The wrought processing tends to align the individual grains in it with unfavorable crystallographic orientation. So this causes a big difference in properties between tension and compression, where you have the compression failing at much lower yield strength than in tension. Another factor, a lot of aluminium extrusions are anodized. You get this attractive sort of clear coating that gives very good corrosion protection. You can't produce a similar thing with magnesium. Usually you require some additional coating. The fact that aluminium is an existing product also helps. There's a huge range of different extruded sections on the market to select from, whereas sourcing of extruded magnesium is quite difficult. So this is an issue for somebody trying to design a new part. Whereas in the case of die castings, you have to make a new die, regardless of whether it's aluminium or magnesium, specific for the component. And magnesium has advantage for castings over aluminium, being much less reactive with the big factor for magnesium is the lower density using for weight reduction. As you can see here, the relative densities of magnesium is 2/3 that of aluminium, a 1/4 of that of steel. But you'll notice that the stiffness and the density are actually proportional. So if you take a ratio of the elastic modulus over density for magnesium, aluminium, and steel, you actually get the same, pretty much the same value. But most situations we're worried about stiffness in bending, and the stiffness in bending increases with the cube of the thickness. So you can design components in magnesium to be considerably stiffer than in aluminium ore. Say something about the research activity. Magnesium seems to get more research focus relative to the actual size of the industry. You know, the number of papers written in magnesium is only half to a third of that in aluminium alloys, despite the usage being 100 times different. And also there's a bit of a skew within magnesium alloy research towards wrought alloys. And we find that wrought magnesium research vastly outnumbers cast, high pressure die cast and other cast magnesium alloy research, which is quite the opposite of what we find in the market. So the overwhelming majority of magnesium alloy applications is high pressure die casting, something like 90%. Both common die casting processes, the hot chamber and cold chamber processes, are suitable for magnesium. In comparison, aluminium is really only used for cold chamber process, and the other main metal used for hot chamber is zinc. So magnesium has a significant advantage in being able to be used for the hot chamber process, which has production efficiencies and good yields. Also, the magnesium has an advantage over aluminium because it's much less aggressive towards steels, so you get much longer die life. The heat that you need to remove is less, so the cycle times are better. The main limitation is really the industry size. There is less experience using magnesium and limited recycling. So the applications for magnesium die castings has historically been dominated by automotive applications, and with relatively small applications also power tools and electronics. Now historically we've divided the automotive applications into three segments: structural for the bodies, bracketry, and then powertrain. Powertrain has in the past been tied to the internal combustion engine, and there's been research done particularly on high temperature applications. But with the switch to electric vehicles, there is a major challenge for the use of die casting alloys are based on the magnesium aluminium system. The common alloys, AZ91, AM60, and AM50, have varying amounts of aluminium, and in the case of AZ91, some zinc for additional strengthening. Alloys, magnesium aluminium alloys with additions of rare earths, the cerium and lanthanum rare earths called AE alloys, are emerging as alloys with several advantages: resistant to high temperatures, heat treatable. They give a very good combination of strength and ductility, and have very good castability and resistance to hot cracking.
I think we've just lost the end of that slide presentation. That was a really fascinating presentation from Professor Abbott in terms of, he apologised he couldn't be with us today, but due to the time difference, I think it was 2 a.m. in the morning where he is at the moment. So he sends his apologies, but hence he sent the recording. But I did find that very fascinating in terms of how much research is actually done on magnesium compared to aluminium. That really is fascinating. So thank you to Professor Abbott for sending in that recording to us. I'd like to now welcome Dr. Professor Murugan from Parliament Engineering College near Chennai, and I will hand the platform over to you, sir. Thank you, Professor.
So thank you, sir. Am I audible?
Yes, sir, you're audible. Yes.
Oh, thank you. I'll share my PPTs.
Just getting the presentation up now.
1 minute.
Okay, presentation's up.
I'll make it full screen. Oh, yes. I think my PPT is visible to you.
Yes, we can hear you.
Yeah, thank you. So first of all, I thank Dr. Venkatesh and Makhan Singh of Birmingham City University, UK, and the International Magnesium Association for giving this wonderful opportunity for the Panimallar Group of Institution. So on behalf of Panimallar Group, I am representing here. So I am Professor Murugan, Department of Mechanical Engineering in the Panimallar Institute of Technology. So as I think most of the industrial persons covered the about the magnesium alloy and everything. So as an academician, so I have given the topic as a overview, a brief overview about the magnesium alloy. So my presentation will go in this way. So the introduction and the need for lightweight metal, advantages of magnesium alloy, then prominence of magnesium alloy, applications, and the resources available in our country. Then if we take magnesium alloy in our academic curriculum, what are the topics we have to consider? That is the thing we are going to see. So as an introduction, but since from its discovery of magnesium, that is in the year 1808, so the magnesium is used in the military and defense application initially. So later on, because of its inherent properties like low density and high strength of these magnesium alloy, the application of this magnesium alloy is emerging in all the areas, especially in the automotive and aircraft engineering. And because of the biodegradable nature of the magnesium alloy, so the magnesium alloy is now it is used in the as a biomaterial in the biomedical field. So since the applications of magnesium alloy is emerging in all the areas, so the annual growth rate of the magnesium market is increasing around 1.6 million metric tons expected in the year 2027. As we aware of that, in the automotive and the aircraft industries, so we have to reduce the carbon emission as well as we have to increase the fuel efficiency of the vehicles. So we need this demand can be achieved only by using the lightweight alloys. So in the lightweight alloys, so the magnesium alloy plays a vital role in case of the lightweight alloys. So in the current scenario, so we are using the aluminum alloy for this engine application and other structural applications. But this magnesium alloy going to be play a vital role in future because the advantages of the magnesium alloy, because the magnesium alloy is 36% lighter than this aluminum alloy and 78% lighter than the iron. So, and also in alloyed form, the highest strength to weight ratio is achievable for the magnesium alloy. So that is why this magnesium alloy is going to be rule the automotive and aircraft industries in the near future. And some prominent properties in the magnesium alloy. So magnesium alloy, actually the crystal structure of the magnesium alloy is hexagonally close packed crystal structure. So because of this structure, at room temperature level, it exhibits only limited ductile property or ductile nature, but it has a super elastic behavior, which according to this super plastic behavior, the magnesium alloy will exhibit very high ductility at elevated temperature, more than 200 times of elongation is possible. So because of this superplastic behavior, the magnesium alloys can be used for making complicated shapes of final product in the automotive and the aircraft industries. And magnesium alloys are used in automobile and aircraft applications. There are so many components are manufactured using the magnesium alloy. Maybe body parts or powertrain parts or chassis parts. So all the parts are manufactured using the magnesium alloy, and very few parts shown in this slide. And also in the aircraft application, so many of the components are manufactured by using the magnesium alloy. And for example, if you take the aircraft company Tupolev, it is using around 1,325 magnesium components, which weighs around 70-80 kg. So this magnesium alloy offers very high strength to weight ratio. This is the reason they are using. And not only in aircraft and automobile application, the magnesium alloys are used in the many consumer products and as well as the electronic industries. So most of the exterior panels of laptop, cell phone, cameras are made of magnesium alloy. And coming to the resources available for magnesium in our country, India. So there are very vast resources available for magnesium in the form of seawater as well as the high-grade mineral deposits. So if you measure the total reserves and remaining resources available in our country is around 394 million tons. So then if you see the availability of resources in state-wise, so nearly the 3 states holds the 98% of the resources, namely Uttarakhand, Tamil Nadu and Rajasthan, like that. And as I told, if the magnesium alloy is introduced in an academic curriculum, so these are the topics we can consider to make a dedicated subject for this magnesium alloy. First, we can give important to these resources available for the magnesium alloy and how to extract the magnesium from these resources. We can get details, and then what are the available production techniques for the magnesium alloy. We can concentrate as a single unit. Then we can go to the next one, classification of the magnesium alloy, and for each magnesium alloy, what are the chemical compositions, and microstructure also we can teach to the students, and how the magnesium alloys are designated by using the ASTM standards, that we can teach. And then what are the effect by adding the different metal elements or rare earth elements, by adding this to magnesium, what are the effects, we can detailedly explain them. Then what are the physical and mechanical properties of magnesium alloy, we can teach them. Then most importantly, the phase diagram of the commercial magnesium alloys can be taught to the students. And another unit, we can concentrate on the joining, mostly how the magnesium alloys are joined by using welding process. And we can focus on the application side. What are the various engineering applications and engineering applications of magnesium alloy? And then now recently the magnesium alloys are used in the biomedical field also. So we can touch upon these applications also. So these are the suggested topics for the magnesium alloys if we include in the curriculum. So thank you. Once again, I'll thank for this opportunity given to the particular group of institution. Thank you, sir, Makhan sir, and thank you, Dr. Venkatesh.
Thank you so much, Professor. It was a wonderful presentation, and it's so nice to see the perspective from academia, because I guess one of the things that we're very keen on doing is educating young minds on magnesium and in terms of its great properties, and kind of creating that ecosystem where the young students of today are going to be the next generation of future engineers looking at things like electric vehicles and also electric aeroplanes one day, etc. And so it's very important that we look at redeveloping and redesigning curriculum in India that looks at magnesium, not just for those students that are studying materials, but those that are also studying automotive engineering, mechanical engineering, so that we get a wide spectrum of young people understanding and appreciating magnesium as a material. Thank you again, Professor Murugan from Palamila Engineering College in Chennai. So I'm now going to just slightly tweak the agenda. We were going to have a question and answer session now, but I think it'd be good to merge that together with the closing remarks with Martin Tauber of the International Magnesium Association and also Dr. Vijay of Birmingham City University. So I'll hand over to both Martin and Vijay to give their closing remarks and also take any questions that we may have in the last 5 minutes before we close. And if both Martin and Vijay could just relay their details to the audience. So if there are any questions post the event, well, they can be contacted. Over to Martin and Vijay. Thank you.
Hello, thank you very much, Makhan. Fascinating afternoon over here. Thank you all very much. And it was a pleasure to listen to all of your valuable contributions during this webinar. And in addition, of course, I would like to thank also our European chairman, Ken White, who was also very engaged and involved in setting up this event today. And of course, our long-term member, Birmingham City University, and of course, Makhan Singh, who is a long-term supporter in setting up such events, but also keeping the bridge to India for IMA and for our members. I want to reach out to all of you to join the IMA and PCU to intensify our presence with our industry stakeholders in India. Today's webinar has already proven that our IMA members having a strong and long-term business relationship in India, and the IMA would like to build on that and is planning to launch an IMA India committee where current and future market participants can come together to build a solid foundation and a prosperous future for magnesium in India. We heard about the potential in the transport market, but we have given you on purpose a wider perspective today. We've also an outlook in the steel market, because magnesium is used there as well, to provide you a whole spectrum what IMA can provide and what IMA members are doing. For the committee, we'll search for a chairman from India industry or university, and perhaps the chairman is already among us today, and PCU and Makhan has agreed to facilitate this process, and also that PCU will remain as an active supporter of this committee as well. So we're reaching out to companies, institutes, universities, and individuals to join our activities. Please get in touch with us when you're interested with us on this journey, and we'll keep you updated about the next steps. With this open invitation, I'm going again. Thank all participants for their to present, and for the audience to be present, and also to ask questions shortly. And with that, I hand over to Dr. Vijay from BCU. Thank you, and see you next time.
Thank you so much, Martin. First of all, I would like to thank Reese and Phil, because without his support, we won't be here in this wonderful platform. So with that thank note, I would like to say, so I would like to support you guys in terms of how magnesium, as rightly pointed out by Professor Murugan, taking into academia, because we believe in a healthy ecosystem brings more creativity and also more concrete way of going forward. So I'm here to support in terms of Indian academic universities, how they want to be a participant and going forward. So I'll share my details with you all. So if you want to reach out to me in terms of any queries regarding to academia, you can. Thank you so much for that. And I'll pass it over to Martin and Makhan, and we can have some question and answer session.
Brilliant. Thank you, Vijay. I think the first question we've got a hand raised from Dr. Saurav Ganguly. So, Reese, are you okay to unmute Dr. Ganguly to ask his question?
Yep, of course. I'm just going to unmute.
Hello, can you hear my voice?
Yes, sir, we can hear you.
Yeah. I am Dr. Let me switch on my video. Hello, I am Dr. Saurav Ganguly, scientist from CSIR IMT Bhubaneswar in India. I have been working in magnesium alloys and composites for last 6 years during my PhD also, and presently also I am working. And so I have been continuously looking into IMA events and all those things, their notes and all that. They have been very helpful for my work. And I thank IMA to giving this platform to discuss about magnesium and its prospects in India. My only question is that since India has a big reserve of magnesite and dolomite, but still the production of magnesium is very not there in India. So accordingly, the market has to be chosen and then production has to be done. Then only the research in magnesium can prosper in India. So what are the views? I want to know from your side. How can we? That's all.
Thank you, Dr. Ganguly. I don't know, Martin, if you want to. The question, I suppose, is very much, there seems to be the ability to perhaps produce magnesium, but how do we increase the appetite for magnesium with the OEMs? And but a question maybe both to yourself and Vijay and Ajay, who's on the call as well.
Yeah, I think Makhan, thanks first of all for the question, which has of course a lot of perspectives. One perspective is the primary production. I think that was referred to as well, because it was asked. There's a lot of dolomite and magnesite as a possible raw material. We all
and also
know,
cardinalite from the seawater.
Yes. Yeah. Thanks. Yeah, I think that we all know that the last decade and even longer, the primary production is mainly dominated by China, with a few exceptions, which are plants which are for a couple of years already in production. There were no new primary production going on stream within the last years, exception in Turkey. Within the supply crisis now, I think, which has started September last year. The question came up again and is currently discussed on a global level. And perhaps we will see a primary plant in India as well. The other perspective of the question is, of course, the demand here, and demand. I think we can support, we can encourage with our activities. But I think that within the electromobility, especially in the two-wheeler and three-wheeler market in China, once the potential of lightweight with magnesium is realized, we will have a great potential there.
Yeah, just last one information. Since in India, the steel industry, automotive industry, all are blooming now. They are very greatly increasing. So it would be better if industries can join, industry institute can join together, and then they can develop magnesium production. So it will be a very good for the market also, as well as for the institutes as well.
Yes.
I think that was a great comment there. Thank you, and a great question,
Thank you,
Dr. Ganguly. I think it's a good point, and I guess that's what Dr. Martin and Dr. Vijay have been saying. Is we're now looking to set up an India committee to look at magnesium, and if there are any people on the call today who would be interested in taking part of that committee, please do contact Dr. Martin Tauber and also Dr. Vijay. Dr. Vijay will be based in India for 3 years in Ludhiana at the MBCIE project in Ludhiana, which will be an innovation center. So I'll invite Martin and Vijay, if you can both put your email addresses in the chat box, and should anyone wish to have any more questions about.
Makhan, sorry, there is one question that in the chat box. I think maybe if Ajayji is here, he can try to answer. Ajayji, the question probably is right in your perspective. How big is the magnesium market in India today?
Let me share with you all that as far as Indian market is concerned, as I said, that we are entering into the e-mobility business, and that traction has started off, and momentum is being set now. And frankly, in India, as I said, that the basic design of the vehicle out of aluminium or out of magnesium, or we call it as a hybrid design, is yet to take off. But yes, all having said that, there is a huge potential for Indian market to absorb metal like aluminium as well as magnesium, because India is one of the top country wherein the consumption of the vehicles is very high, mainly because of the reason urbanization is going very fast in the country. Second thing is that rapid mass transport system has reached to only few metro stations, metro cities only. It has not spread across the country. So there is a huge potential for two-wheeler as well as bicycle industry as well as auto industry for the uses of the magnesium. It goes without saying, but it is very important that industry and the research and development departments have to understand the uses of magnesium for its conversion into the parts which is required by the auto industry. So as of now, I would say it is in a very nascent stage. And that's to the best of my knowledge. Probably other specialists who are there in the forum, they can put more light onto the subject. But to my knowledge, as of now, we are trying to use aluminium, and then magnesium is also one of the potential products that we can make use of. So that's my take about the subject.
Thank you so much. Fernando, hope that answered your question, I believe. So Makhan, it's back to you.
Thank you, Vijay. So I think we're approaching the close now at 3:15. So I just wanted to give the platform to yourself and Martin for any final thoughts before we formally say thank you to everyone and sign off. So just to say some final remarks from Martin and Vijay. Thank you.
Yeah, if I may start, I'll just repeat my appreciation for everybody but also to Rick McQueary, our IMA president, for his kind introduction today, and also his invitation to our World Conference in August from 29th to 31st in Barcelona in Spain. So that would be, if anybody has a great presentation on hand, and to send in an abstract, and also to if you have a great part or great application or technology, we also will give our yearly awards of excellence, and there's also the possibility to send an award nomination in as well. As Vijay said, we're gonna place our emails in the chat, and we will also make this webinar recording available, so you can revisit. I may will also post it on the YouTube channel, and let's keep the communication open. Thank you very much.
Thank you so much, Martin. And from my side is I put my email address. So academics and any institute who wants to get involved with this wonderful initiative, please do reach out to me. Thank you so much.
Hi.
Yep.
Hello, Mr. Dr. Tauber.
Yes.
I'm in a very remote area and watched the whole thing. Sorry, it's very difficult here. I want to say something to this meeting today. Maybe you are aware, we are in India, personally I am, since 2002. Yep. And we did the first things in Sundaram and Clayton for magnesium furnace.
I'm not too sure what happened there.
Yeah, I think we lost him. It's okay.
Yeah,
that's fine. We can. Yeah, it's okay. We can address him if he reaches out to myself or Martin in email. No problem. So Makhan, do you want to close?
Sorry, maybe it's important that everybody hears what he has to say. So probably if you still hear us, please type in the chat. We can wait a minute or so.
Sure.
I think his internet connection was low, hence why he might have vanished. So,
yeah.
But hopefully he's got details from the chat box, and he can be in contact.
I'll have the attendance list, so whoever attended today will get the list of, so we can get that contact information for them.
Thank you.
Wonderful.
Okay, I'm just going to stop the recording now.
Wonderful. Thank you, Reese. Thank you for an excellent